Hey guys, today I will be giving an overview of groper nutrition. To address this topic, I will outline the following: groper in aquaculture, basic fish nutrition, groper feeds, protein and lipid requirements of juvenile groper feeds, carbohydrate requirements, micronutrient requirements, and taste enhancers. The aquaculture of groper is a valuable aspect of the aquaculture industry, with approximately 651,000 tonnes being produced annually around the world. This brings in a market value of $2.74 billion US. Most of this production comes from three countries: China with 65% of production, Indonesia with 11% of global production, and Taiwan with 17% of production. This isn't just one species being produced. There are approximately 47 groper species as well as 15 groper hybrid species that have been trialled or are currently being produced through aquaculture around the world. With such an important industry to global food production, an understanding of nutrition enables individual aquaculture operations to maximize groper production by encouraging growth, well-being, and immunity, as well as decreasing total mortality. A solid understanding of nutrition will also increase profits by the formulation of cost-effective feeds. As stated before, there are many groper species, each with different dietary requirements, and so optimal dietary formulation is required for each species. Fish nutrition basics. Before I address the nutritional requirements of groper, I will briefly run over the basics of fish nutrition. Fish grow well on natural diets that provide nutrients in amounts enough to meet their metabolic requirements. The essential nutrients are amino acids, fatty acids, vitamins, minerals, and energy-yielding macronutrients, namely protein, lipid, and carbohydrate. Diets for fish must contain all the essential nutrients and energy to support growth and general well-being of the fish in aquaculture systems. So, what foods do fish get these nutrients from? Proteins, which are made up of amino acids, can be found in food such as fish meal, blood cell meal, soybean meal, brewer's yeast, feather meal, and fish meal, just to name a few. Each of these have differing levels of digestibility, with sources such as blood meal having high crude protein content, which is highly digestible. Faba beans, on the other hand, have low crude protein content with low digestibility. Oils, which are high in essential fatty acids such as EPA and DHA, can be sourced from coconut oil, maize oil, palm oil, soybean oil, olive oil, sunflower oil, krill oil, anchovy oil, sardine oil, just to name a few. Carbohydrates in fish feeds are present as starches from various sources, such as potato or corn, just to name a couple. Groper feeds, protein and lipid requirements. I will now talk about the protein and lipid requirements of groper. Groper are highly carnivorous and require significant proportions of dietary protein and fat for normal growth. Most of the published data on nutritional trials are based on juveniles. Many investigations have suggested their protein and lipid requirements to be in the range of 40 to 50% and 8 to 16% respectively. In captive stocks, when protein level in the feed is reduced below the optimum level, the fish consumes more feed to get the requirement of protein and calories for growth and metabolism. Optimizing feed composition supports growth and helps in reducing the amount of feed, which in turn has economic implications. Many investigations have suggested their protein and lipid requirements to be in the range of 40 to 50% and 8 to 16% respectively. The differences pertain to lipid and its proportion with protein. For Malabar groper, increase in lipid to 12% improves the feed conversion ratio as well as the growth rate. Increase in lipid content to 16% decrease the food conversion ratio in brown marbled groper and polka dot groper. A carnivorous fish, like the hybrid groper, has enzyme systems for protein-rich food of animal origin and might neither accept a predominantly vegetarian diet nor digest it effectively. However, it is possible to develop formulated feeds with a balance of nutrients derived from sustainable sources that can meet the physiological requirements of the fish. Previous articles have discussed the urgent need for substituting the fish meal and fish oil with alternate sources of nutrients. Some plant-based sources already being used as a partial substitute include sunflower and linseed. However, they do not contain omega-3 fatty acids, which are essential. Protein and lipid requirements of juvenile groper. Juvenile groper may have slightly different nutritional requirements compared to mature groper. I will briefly go over 3 different species and their nutritional requirements in the juvenile stage, based on information from various studies. A study by Williams et al., published in 2004, showed that diets for juvenile polka dot groper should contain not less than 44% digestible protein and at least 15% lipid. It's been suggested by Geary et al., an article published in 1999, that juvenile humpback groper should receive 54.2% dietary protein for maximum growth, with weight gain and feed efficiency being higher with a 9% lipid diet than compared with a 3%, 6% and 12% lipid diet. A follow-up study, published by Williams et al. In 2004, stated that juvenile groper should not contain less than 44% digestible protein, and that lipid content over 15% will increase fat deposition, reduce food intake, and slow growth rate. Geary et al. Published another article in 2004, showing that the optimal dietary crude protein and lipid specifications for juvenile tiger groper are 47% and 9% respectively. Surya et al. Published an article in 2004 exploring the effects of differing HUFA levels, which is highly unsaturated fatty acids levels, in juvenile groper diets, and found that humpback and tiger gropers should have no less than 1.5% and 2.5% HUFA respectively, whereas Malabar groper require approximately 1%. Groper feeds. Carbohydrate requirements. As a cheaper energy source than either protein or lipid, carbohydrate should be considered when formulating cost-effective and environmentally friendly compounded groper grow-out feeds. Generally, the carnivorous marine fish are not as good as herbivorous or omnivorous freshwater fish in utilizing carbohydrate as a source of energy. Carbohydrates provide aquaculture workers with a way to spare lipid and protein, which can reduce the feed oxidation and ammonia release into the environment respectively. A study by Xiu and Lin, published in 2001, investigated the carbohydrate utilization and its protein-sparing effects in diets for Malabar groper. They found that decreasing the dietary protein level from 46% to 42% by increasing the starch content in the diet from 19.5% to 24.6% did not reduce weight gain and food efficiency, suggesting that starch could spare some protein when the dietary protein level is low. A study done on juvenile red spotted groper calculated their optimal carbohydrate amount was 7.4%. To understand which sources of carbohydrates provide groper with better nutrition, I will outline 2 studies. In the first study by Palinggi and Geary, published in 2004, humpback groper were fed diets with the same amount of protein and lipids, but differing dietary carbohydrates. They found that the type of carbohydrate in the diet affects the apparent digestibility of both NFE and protein, but not lipid, and consequently growth rate, feed efficiency, and nutrient retention responses of humpback groper. The best dietary carbohydrate source for juvenile humpback groper is glucose, followed by dextrin, starch, and sucrose. These findings are illustrated in the picture on the right, with the carbohydrate glucose evidently reaching the highest blood plasma glucose levels. In the second study, which was an exhaustive study on hybrid groper by Shapawi et al., 4 experimental diets containing carbohydrates from different sources, namely tapioca, corn, sago, and dextrin at the same inclusion level, were tested. Results of this trial showed that the body weight gains were higher with tapioca, corn, and sago than dextrin. Net protein utilization was maximum with corn diet, followed by dextrin, sago, and tapioca. Food ratio and protein efficiency ratio were not significantly influenced by these sources of carbohydrates. These results are displayed in the figure on the left. Micronutrient requirements. It's not just protein, lipids, and carbohydrates that make up the requirement for groper feeds. Micronutrients are vital too. One of these micronutrients is ascorbic acid, aka vitamin C. This micronutrient is involved in promoting growth, normal skeletal development, and general health. Most fish cannot synthesize this endogenously due to lack of certain enzymes, and so they must include it in their diet. Shapawi et al. Published an article in 2019 which stated that grouper require 156 milligrams per kilogram of dietary ascorbic acid in the feed for optimum growth and development. This study also found that a lack of this acid did not affect the survival of the groper, but increased occurrence of deformities. The occurrence of these deformities associated with a lack of dietary vitamin C is shown in the graph on the right. Taste enhancers. It is important to point out that the alternate protein sources, especially from plants, are associated with a palatability problem in carnivorous fish, leading to the rejection of the diet, even if it is balanced in nutrients. Shapawi et al. In an article published in 2019 demonstrated that betaine was an effective ingredient that encouraged feeding in groper. This ingredient is commonly found in sources such as beets, spinach, and many others, from where it can easily be extracted. There are several ongoing studies on the nutrition of groper, and most of these are focused on producing eco-friendly and nutritionally balanced feeds that are also readily acceptable to the fish. Just to reiterate my key points here, groper aquaculture is an expanding industry with significant market value. Groper generally need between 45% and 55% protein in their diet, as well as 8 to 16% lipids, depending on the species. Varied amounts of highly unsaturated fatty acids are also required. Carbohydrates, mainly starch, can be used to spare protein and lipids, resulting in reduced costs. Micronutrients such as vitamin C needs to be considered when formulating feeds. Remember that there are slight differences between juvenile diets and mature groper diets. Taste enhancers such as betaine help to encourage feeding in groper. In conclusion, it's important to understand all of these aspects of groper nutrition in order to increase growth, improve well-being, and decrease mortality. Thank you.